So I'm going to present some sample problems regarding our module number 2, Kinematics of Translation, Freefall, and Projectile Motion. So this video will help you to solve the problems regarding in our module number 2. Okay, sample problem in Freefall. The time an apple falls from a tree is freely falling in 0.5 seconds. What is the final velocity of the apple? Where the given acceleration due to gravity is 9.8 meter per second squared. In solving word problem such as this one, we must identify first the given, required, equation, solution, and answer. Okay, so let's solve problem number 1. In our problem, we have given value. So we have the final time, which is 0.5 seconds. Acceleration due to gravity is constant 9.8 meter per second squared. The initial velocity is 0 meter per second, and then the initial time is 0 meter per second. The initial velocity is 0 because it came from rest. So what is the required? Required sometimes referred to the unknown value. So here in our problem number 1, we are tasked to find the final velocity, which is BF. Okay, so what is the equation? For us to find the final velocity, we must use the formula A is equals to BF minus VI, or the initial, divided by the final time minus the initial time. Okay, and then after that, we will just transpose all the value to the given equation. A is 9.8 meter per second squared is equals to the unknown, which is VF, minus the initial velocity 0 meter per second, divided by the final time 0.5 seconds, minus the initial time, which is 0 meter per seconds. Through cross multiplication. So VF multiplied by 1 and 9.8 meter per second squared multiplied by 0.5 seconds. So after we cross multiply, it will become 9.8 meter per second squared multiply by 0.5 per second is equals to final velocity. So this time, we can now find the unknown by multiplying these two values. So 9.8 times 0.5 is 0.05 meter per second, and that is the value of final velocity. Okay, so now let's solve the problem. 9.8 meter per second squared is equals to VF minus 0 meter per second is VF, divided by 0.5 seconds minus 0 meter per second is 0.5 seconds. So now, from this, we can find the final velocity. So next, I will be discussing how did we get meter per second as the unit of the final velocity. So here, it is important to have unit. Okay, so meter per second squared multiplied by second. So just cancellation. So therefore, the unit is meter per second. So that's how we get the unit. Problem number 2 is about acceleration. So the statement is, how long does it take to increase a cart velocity from 5 meter per second to 10 meter per second if the cart can accelerate at a rate of 1.5 meter per second squared? So same process, we must find the given, required equation, solution, and answer. In our problem number 2, the given are the final velocity, which is 5 meter per second, initial velocity, which is 10 meter per second, and then the acceleration, which is 1.5 meter per second squared. So now let's identify what is the required or the unknown. Here in our problem, we are asked to find the time. Okay, because how long does it take? So t is the unknown or the time. What will be the formula we need or the equation we need to solve the problem? The equation is A is equals to delta V divided by the time. So this formula can be expanded if our given have indicated the final and initial velocity. So it will become A is equals to initial velocity minus the final velocity divide the time. As you can see in our given equation, the unknown is acceleration, but our required or unknown is the time. So we need to derive the formula. So how can we derive the formula? We must cross multiply the this side or the acceleration multiplied by time, and then initial velocity minus final velocity multiplied by 1. Okay, so it will become A times time equals to initial velocity minus the final velocity. To cancel A, we must divide both sides by A. So bring down A and then cancel. So the formula we're going to use is T is equals to initial velocity minus final velocity divide A. So now we already have the formula for the time. So we will just transpose all the value in this formula. So T is equals to the initial velocity, which is 10 meter per second, minus the final velocity, 5 meter per second, and the acceleration is 1.5 meter per second squared. So first, 10 meter per second minus 5 meter per second, that is 5 meter per second divide by 1.5 meter per second squared, and that will be the value of time. If we divide 5 divide 1.5, the answer is 3.33 seconds. So this is the final time. Problem number 3 is solving for the speed and velocity. So the statement is, a lady walks 10 kilometers to the west in 4 hours and 3 kilometers in 2 hours in the same direction. find the average speed and velocity for the whole journey. So, in solving this one, same process, we must find the given, required, or the unknown equation or the formula, solution, and then the last is answer. So, don't forget the unit of each answer. In problem number 3, we have 4 given value. We have the final distance, which is 10 km west. The final time is 4 hours. The initial distance is 3 km west, and then the initial time is 2 hours. So here in our problem number 3, the unknown is the speed and velocity. So the unit is V, and we have this one. Okay. So what is the formula in finding the speed? So V is equals to delta D over delta time. Okay. And then in finding the velocity, we have V is equals to delta D over delta time. So as you can see, it is just the same, almost the same formula. But the difference, in finding the velocity, we must indicate the direction. That's why it has some arrow here. Okay, so it indicates velocity. We can expand our formula because it is given as delta D and delta T, and our value here is final and initial velocity. So in expanding this formula, we can have V is equals to initial distance plus the final distance divide the initial time plus the final time. Same with the velocity. Okay, so velocity is equals to initial distance plus the final distance divide the initial time plus the final time. First, let's solve for the speed. So we will just transpose all the value here on our given equation. So V is equals to 3 km plus 10 km divide by the time, which is 2 hours plus 4 hours. Okay, so first solve this one. 10 plus 3 km is 13 km, and 2 plus 4 hours is 6 hours. So the final speed is 13 km divided by 6 hours is 2.17 km per hours. Okay, so this is the answer for the speed. So let's have the velocity. So this is the expanded formula for finding the velocity. We will just transpose all the value, same process with the speed. Velocity is equals to initial distance, which is 3 km west plus 10 km west divide by the time, 2 hours plus 4 hours. Okay, so same process, 3 km plus 10 km that is 13 kilometer west. So 2 plus 4 hours is 6 hours. Therefore, 13 divide 6 hours, we have 2.17 kilometer per hour west. So the answer in velocity must indicate the direction. So here, the direction that the lady traveled is 2.17 kilometer per hour west. Problem number 4. So this is about the solving projectile motion. So I know if you already scan or read our module number 2, projectile motion is kind of tricky. So it consists many formulas. Okay, so you must listen to this problem. A boy throws a rock horizontally out of the window with a velocity of 20 meter per second. If the window is 3 meter above the ground, then how far will the ball travel before it hits the ground? Find the displacement for x-axis using the formula and use the formula of t, or time, is equals to the square root of the distance in y-axis over a, or acceleration, for finding the time. So it is a series of computation. So first we must find the time before we can find the distance in x-axis. So now let's identify the given values based on the word problem that is presented in number 4. So first, the distance in y direction is 3 meter. The velocity in x direction or x-axis is 20 meter per second, and then the acceleration is 9.8 meter per second squared. So what is the required or the unknown? That is the distance in x-axis, or what we call the range. Before we can find the range, we must use the formula of time, which is square root of 2 dy over a. So we must find first the time before we can find the distance in x-axis. So what is the formula for distance in x-axis? So that is dx is equals to vx times time. Let's solve for the time. So this is the formula for time. T is equals to the square root of 2 dy is the distance in y-axis. So that is 3 meter divided by the acceleration, which is 9.8 meter per second squared. So t is equals to the square root of 2 times 3, that will be 6 meter, divide 9.8 meter per second squared. So here, we can now cancel meter para yung seconds na lang po yung matira for the unit of time. So, this square root of 6 meter divide 9.8 meter per second square, that will be time is equals to 0.78 seconds. This is the value for time. So since we already have time, we can now solve for the distance in x-axis or the range. This is the value of time. Our formula for the distance in x-axis is dx is equals to vx times time. Okay, so we will just multiply. Dx is equals to 20 meter per seconds, and time is 0.78 seconds. So the distance will be 15.6 meter. So bakit meter na lang? We can cancel s. So the unit for distance is meter. Therefore, our answer is time is 0.78 seconds, and the distance in x-axis is 15.6 meter. Okay, so that is how we can solve for the projectile motion. So last problem for projectile motion. So number 5, a doll was thrown vertically upward with a speed of 4.9 meter per second. What is the time of flight? Okay, so how can we answer this problem? First, we must identify the given values, the required or the unknown, the formula and equation for the write the complete solution, and then the answer. So let's identify the given value for last problem. So the initial velocity in y-axis is 4.9 meter per second, and the final velocity is 0 meter per second, while the acceleration is negative 9.8 meter per second squared. It is negative because it is going down and it is vertically. So here in our problem, it is also identified that the final velocity is 0 meter per second. So what is the required or the unknown? That will be the time. The question is, what is the time of the flight? Therefore, the equation we will be using for this problem is Vy is equals to, or the final velocity is equal to the initial velocity plus the acceleration times time. Okay, so to solve this problem, we must transpose all the value here on our given formula. So Vy, or the final velocity is 0, equal to initial velocity, which is 4.9 meter per second squared, plus the acceleration is negative 9.8 meter per second squared multiplied by the time. Okay, so to solve this one, we must simplify this. Okay, so after we simplify, we must transpose 4.9 meter per second to the other side. So it will become 4.9 meter per second equal to negative 9.8 meter per second squared time. So to cancel the acceleration, we must divide it both sides. 1.8 meter per second squared, 4.9 negative 9.8 meter per second squared. So we can now cancel. So time is equals to 0.5 seconds. Okay, so the answer is this one.